Hello everyone. Hi everyone. Am I audible? Today's topic is welding and let's start. First I will share my screen. By the way, how are you all? Hi Ravi. How are you?
Yes, bro. Yes, bro. I'm fine. What about you?
Yeah, I'm great. I'm great.
Yes, yes. Continue, continue.
Yeah, okay. Is it visible? Hello. Please say I'm not able to see you all. Is it visible to you? Hello. The-
Yes, 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 bro. Is it visible?
okay. So first we talk about gas welding. Gas welding. It is oxyacetylene gas. What is oxy? Oxy means oxygen, and acetylene is a gas that is used uh, for burning. Okay, for to give flame. So let's see the definition. Oxyacetylene welding. Wait 1 minute. Okay. Oxyacetylene welding is a process that uses a combination of oxygen and acetylene gas to produce a flame. Who is coming here? Okay. So this oxyacetylene welding is a process that uses a combination of oxygen and acetylene gas to produce a flame with a high temperature for welding and cutting metals. So it is used for welding and cuttings. Okay, and here we can see its flame. Its flame reaches around 3500 degrees Celsius and Fahrenheit. So here we can see that the temperature is not exact. It can vary depend on it may depend on the what kinds of what are the material we are using. So temperature is not exact. It will vary from material to material. So the noticing things is here is equipment. We can see the oxygen cylinder is black in color. Okay, so maybe they will ask the color of cylinder. So it is black always. You can see in hospital also black color, and the neck is white. Okay, and the acetylene cylinder is maroon color. You can see here. Uh, this is the acetylene cylinder and the oxygen cylinder. These are the pressure regulators and welding torch. These are the components. Okay, so welding is very easy. You just have to remember the components, what components is used. And now today we are only discussing basic weldings. Okay, no, not so detailed. So one point I will suggest you to remember the cylinder colors in gas weldings. So gas welding is also known as oxyacetylene gas weldings. And second is metal arc weldings. Metal arc welding also known as sealed metal arc weldings or stick weldings. These are the weldings. Yeah. So let's look on the components. What we have: power source, ground cable, and these are the electrode holders, wire, flux coating, consumable electrodes, slag, metals, arc, and molted. So we will discuss what is it. So the arc weldings and the MIG weldings all are same. The only difference is gases. So its full name is sealed metal arc weldings. Okay, so this is a definition. You can mug up for the interview. The electric arc formed between the electrode and the workpiece melt both the electrode and base metal both melt. Okay, create a welding pools. What is welding pools? You can see here. It's a welding pools. No, molten welding pools. As the weld pools, the flux coating forms a protective slag shielding the molten metals from atmospheric contaminations. So here, whenever we do weldings, we have to protect it from atmosphere. It means to protect from oxygen. So you can see the gas shield from melting coating. Okay, so this gas protect weldings from air, oxygen. So this flux coating, yeah, you can see that there is electrode and a flux that coated flux help is work as a gas shields. No, it's a protecting layer that protect uh, weldings from air to oxidize. So here we can see that. So main interviewer may be asked the types of polarity. Okay, there are two types of polarity: straight polarity and reverse polarity. So we use DC current. Okay. So what is reverse polarity? Reverse polarity when the electrode, electrode is when this electrode connected with negative terminal, we say reverse polarity, and when that electrode connected with positive terminals, we say straight polarity. So why we do that? So these are 3 points. What are the advantages of reverse polarity and straight polarity? In reverse polarity, the electrode is connected to the negative terminals. Okay, the result in the greater heat. Why we do? For greater heat at workpiece, leading to deeper penetration. Whenever we need to deep penetrate, so we use reverse polarity and faster melting of base metals. That's why we use reverse polarity. Second point, it is often preferred for welding thicker metals, thicker materials, or when deeper penetration is necessary. So these two important points why we do reverse polarity. We can change according to our requirement. And state polarity, the electrode is connected to the positive terminals. Reason: the heat is concentrated at the electrode, causing it to melt more rapidly. Electrode melt more rapidly. Second, the state polarity is often used for welding thinner materials. Here we use thicker materials and here thinner materials. So these are the important points you can remember uh, in arc weldings. So arc weldings, there are three types of arc weldings: metal arc weldings and MIG. It is also arc weldings, MIG welding. Its full name is metal inert gas weldings. So let's look. This is the weldings. Okay. So what is the difference between MIG and TIG? Okay. MIG welding creates an electric arc between, this is the definitions, okay, I will just read. MIG welding creates a electric arc between the workpiece and the consumable wire electrode. The arc melts the wire, forming a weld pool that solidifies to create a joint. Same as metal arc weldings. The second one we have discussed. This one same. So what is the difference? Here is two difference. Uh, First is MIG weldings. We use consumable wire electrodes. Consumable. And the inert gas, what kinds of inert gas we use? CO2 or argon, or the mixture of argon and CO2 to protect from oxidations. So what we use here, metal arc welding to protect from oxidations. Here have flux. We no need gas. In MIG weldings, we use gas. Which gas? CO2 and argons, or the mixture of CO2 and argons. But here we do not use flux. We do not use gases. Here is flux that already coated on the electrodes that help to protect from oxidations. Hmm. So in MIG weldings, we use consumable wire electrodes, and in TIG welding, we use non-consumable wire electrodes. It's a definitions, but not 100% true. I will tell you later. So let's look on the MIG weldings. This torch and the electrode. These are the electrodes used in MIG weldings. It's a consumable. Huh? It consume, it melt and fuse there to join two piece. There are two types of electrode used in MIG weldings. Okay. Here we can say that the cylinder, the inert gas cylinder, what kinds of CO2 and argons. Okay, why we use CO2? CO2, we know that the CO2 block oxygen. You can see that the fire extinguisher is a CO2. Whenever a fire happens, we spray CO2 there because it blocks the oxygen. That's why here we also use oxygen to protect materials. So argon is also used. So you can see that this is the what we can say torch or the holders. Holders have this gas passed through here, and this is the consumable electrodes. Uh, it pass from here, and it will consume, melt, and fuse here. What is arc? This is the arc. Flame is like a arc. So only difference is okay. What is TIG welding? Same definition. TIG welding use a non-consumable tungsten electrodes, okay, to create an arc between the tungsten electrode and the workpiece. The arc generates heat, melting the workpiece and creating a weld. Okay. So what are the inert gas used here? Argon or mixture of helium argon. Okay, we can use argon or the mixture of helium argon to protect from oxidations. So don't confuse in whenever we say the non-consumable electrodes used in TIG weldings. What is non-consumable? This is a non-consumable electrode. This is tungsten. We know that the tungsten have a high melting point. Okay, we use bulbs at home, and it is also in old time we use bulb which is red in color, not red, orange in color. The material inside is tungsten, so it does not melt easily. That's why we use tungsten in welding also, non-consumables. Okay, this is a holder. So what we use to join two pieces, we use another filler rods. So whenever they say TIG welding is a non-consumable, so non-consumable is what? That the tungsten is not consumable, but we use consumable filler rod here to join two pieces. Okay, so this is the TIG welding, same as MIG welding's inert gas supply from here. This is a fixed tungsten electrode. Fixed here is fixed, but in MIG this is not fixed. It comes from here in MIG weldings. The copper I saw, uh, show you a picture before. So we use hand-held welding rods to join two pieces. Same here, we use sealed gas. Sealed gas is used to protect from oxidation, and arc is also there. Next is submerged weldings. What is submerged weldings? This is the picture of submerged weldings. So in this welding, we use granular flux blanket to protect from oxidations. There we use gas. In MIG and TIG we use gas, and in metal arc weldings we do not use gas. There we use flux that is coated on the electrodes. But in submerged weldings we use granular flux blankets, just like a balls, small balls, little bit. You can see the video on YouTube. You will understand. So this is the flux feed. The flux coming from here, and this is the we can say that the holders that hold electrodes. So this is a consumable electrodes used, and the flux used to protect from oxidation, to come in contact with air. Okay, same here is weld pool is generate, and it will fuse there and join two pieces. This is the whole machine, power source. This is the wire reels that used to consume, that consumable, and this is a flux hopper. Here, the granular flux is stored, and it comes from here. Okay, and okay, travel directions. It always move from in this way. Okay, so these weldings are very easy. Just need to remember little bit points. Okay, these are the original pictures. Granules is here, and it come from this pipe, and this is a holder. Okay, this is nothing. Okay, it will not consumable electrodes. I don't know what is it, but here is consumer electrode that consume. This is another picture. You can see this is the same picture. I choose that pictures because you can understand. There is a limitation also. Okay, so the important point in submerged welding is, okay, so this process is often employed in industrials like shipbuildings, pipe and constructions, and other applications requiring deep. Whenever deep welding is required, we use submerged weldings. Okay, and restrictions cannot be used in the vertical. We do not use vertical because granular flux is there. It will not, if we use vertical, it will not stay there. Or overhead welding position, we do not weld, we do not use submerged weldings whenever we have to weld overhead. Okay, so these are the points that we have to remember for submerged weldings. And I have few more pictures. Okay, what is flux? Flux, I told you, in metal arc weldings that is used to protect from oxidations. In some weldings we use gas, in some we use flux, in some we use granular flux. Okay, the weld rod. The welding rod may either be bare or it may be coated with flux. Welding flux is a combination of carbonate and silicate material used in welding process to shield the weld from atmospheric gas. Atmospheric gas is O2, oxygen. Types of welding rods we use for welding ferrous metals, we use steel rod, uh, more silicon, manganese, okay, known as the silicon manganese rods. So whenever we use to weld ferrous metals, we use silicon manganese rods. For alloy, we use this chromium and vanadium and molybdenum are used. Stainless steel 18 by 18 chromium nickel rod are used. For copper and its casting, copper rods are used. So I show this pictures because maybe you can note make your own notes, so that may help you. So these are the basic these are the basics, the weldings. If you have any question, you can ask. Hello. These are the basic weldings we have discussed. So and later we will come with part 2. If you have any question related to this is very easy.
Can you share this PDF?
Okay, I will send in the group. Okay, bye for now. If you have any question, you can ask in the group. We will think to make another video on it, or we will start another session. Okay, bye.